Okay. Introduction to SAP HANA database. For this course, there is no prerequisite. Anybody can attend this course. The target audience for this course is the students, some computer science students, the business students, business information system students, or anyone who is interested in the data analytics. So this is for those. So in this topic, we'll see type of data storages available nowadays. We'll see the strengths and weaknesses of those data storage. We'll try to understand the basics of in-memory database. At the moment, databases are available on the hard disk, but in-memory database, we'll talk about some basic concepts. We'll try to understand HANA and its use in the analytic application, in reporting, and we'll see what are the new functions of SAP HANA XSA extended server, applies. So let's talk about basic concepts of in-memory database. Now, when we talk about in-memory database, that means we are talking of whole database in the RAM. Now, what was the requirement? What was the forces that drive us to move our database from hard disk to the RAM? So one of the driver was big data, predictive analytics, advanced analytical processing, business intelligence. These were the drivers, these were the forces that make us think that we should move our database from hard disk to the RAM. So when I say move the database to RAM, in other words, if you pull the plug and the computer got switched off, so the database is gone. So unless we have the backup of the database on the hard disk. So these were the drivers, the big data. Usually what happens when we need the reports, we have to move the data from our transaction database to the analytical database. And this is not happening all the time. We have to wait for, the people to finish their work on the transactional database. When they go home, then we start moving our database or tables or records from transaction processing database to the analytical database. We do some calculation, we do some processing, we do some aggregation, and then next day we are able to get the reports from the analytical processing database. So the earliest was like, the next day you can get the report. Now, how this was possible to have database in the RAM? Because our hardware innovations, that helped us to move our database from hard disk to in-memory, because we have like high capacity RAM now. We are talking of now terabytes. So terabytes of RAM is available, and it's very cheap, as compared to previously. It's very cheap now. We do have multi-core processor architectures, the CPUs are multi-core processors. Massive parallel, scalings is available. Massively parallel processing is available. When we talk about massive parallel processing, we have lots of computers connected together, and every computer is having its own operating system. And we connect them together, and they are working parallel to process our requests. We do have a large symmetric multiprocessor, means we have like one big computer with one operating system, and he's handling so many processes of our request. So these were the hardware and the forces, the market forces that helps us, that forces us to go for in-memory database. Guys, any question on this part?
I have a question regarding using RAM. You have mentioned that RAM is, if you turn the PC off, it will lose all data.
Yes.
So there's no risk like implement. I know this is like successfully implemented, but I'm just curious how they overcome that.
First of all, they have like, okay, this is for sure that all the data is available in the RAM. And what happens, they do take a backup or snapshots of the RAM, and they put it to the hard disk, But whenever they get a chance, or whenever the certain buffers filled up, they do the backup processes. That is one thing. And secondly, now they are having like uninterruptible power supply, the battery backups and all those stuff are there. So they are kind of safe to do this kind of processing. But this is fact that if we pull the plugs and the computer got shut down, then the database is gone. So we have to recreate the database. We have to do it again from the backup, from the last backup which was available, and we'll put it into the RAM. Yeah. Okay, now if you see here, we have the performance, some bottlenecks. Before, the data was available, if you see on the left side of the hub, we have the hard disk, and then we have the RAM. So we were reading from the hard disk, okay, and we were moving the data to the RAM, and from the RAM it goes to the processor, CPUs. So this was the main this was the main process. Hard disk data moved from hard disk to RAM, and RAM to go to the CPU for further processing. Now, hard disk has a limit. I think it's like it moves like 10,000 cycles per second. So we cannot increase the speed. So that is the maximum limit that hard disk is moving. The disks are moving, and we are reading the data. So that was the kind of bottleneck. If we have lots of data and we want to read again and again, read and move it to the RAM, then it was really, So what they have done, they just remove the hard disk, and now all data is available in RAM. And now from RAM to CPU. So before, the bottleneck was from disk to RAM. Now the bottleneck is shifted from RAM to CPU. Now they're working on that kind of, the latency between the CPU and the RAM. But having a data in the RAM is like a huge improvement in data processing. So at least you can say 10,000 times faster, because the bottleneck of the hard disk, which was like 10,000 cycles per second, is gone now. So the data is available in the RAM, and we are just we are not waiting for the cycle to complete and then we can read the values. Now, the hardware innovations that helped us. At the same time, software also, helped us in having a database in the RAM. So both things helped us. We do have, if you can see here, we have the advanced partitioning, data partitioning, and the compression of database is possible. When I say compression means we are storing, imagine like if you have a data on database, like maybe you can say 20 gigabyte or 25 gigabyte. When we compress the data and we put it into the RAM, it becomes like, 5 gigabyte or 3 gigabyte, something like that. So much compression. If the data is available on the hard disk, then we used to do the aggregation, aggregation means that we process the data and we do some kind of calculation and we store at a certain stage. From there, we can read and we can do the processing for reporting. Now, imagine if we have like sales, okay, we are selling the items, like think for an example of Amazon, and they are doing like I'm not sure, millions of transactions every day, something like that. And if you have like 30 days, like 30 millions of transactions. Now, if you have to process at the end of the month, if you have to process then you are processing, 30 million transactions, and then you're getting the reports. So it was like, very difficult to get the monthly report at the end of the day, that how much sales we have made. So what companies used to do, so when they move the transaction from OLTP, yani transaction database, to analytical database, they do the aggregation. Aggregation means that, okay, since we know that we need the sales at the end of every month. So what we do, we do the calculation of 1 million sales, and we add them up, and then we get one record that has the sales of that particular day. So we transfer that one record to the analytical database. So this is what we call aggregation. So after 30 days, instead of having like 30 million records to process, we have like 30 records to process, because every day we have one record that has. So that was the aggregation that we used to do when the data was on the hard disk. But now, since the data is in the RAM, we don't have to do the aggregation. We can process 30 million transactions on a fly whenever we need it, and we don't have to worry for the speed of the hard disk or speed of the computers or something like that. And since we have the all detail of data, that is another advantage. We can drill down to any information. Before, we were having limited choices to do some analysis or something like that. But now, since we have the whole detail of database, we can go for any detail, any kind of report. Any question here, guys? When I say that we have like data partitioning, there's not only a one RAM actually. We have like stacks of RAMs. We have like stack of servers that we have one server, another server on the top of each other, and they are all in cupboard. So it's called stack of computers. Similarly, we have stacks of RAMs, 1 terabyte, 2 terabyte, 3 terabyte, and we can have like 128 stacks, different computers that have RAM, and all those 128 computers are connected, or servers are connected to each other, and we can do the parallel processing on that on the data. So for example, we have a customer data or we have a transaction data that is so huge, so we can split the data table onto different computers, you know. So, and then we will process, all the computers are processing separately, and at the end of the day we will merge the result. So it will be much faster than anything else. We do have, like, if you see, we do have, as I mentioned, aggregation. We don't need to do any aggregation now. We'll do it on the fly. We do have a column store. If you see these lines, this is data is stored in column, not in the rows like in Excel or other databases. So this column store is help in reading the data way faster than we have the data in the rows. We'll talk about that, inshallah. Compression, you know, we'll talk about the compression as well. We compress the data. How we compress the data, we'll talk about that. You know, the computers work very fast on numbers, but it works very slow on the text. So what we do is we actually we shifted our data to the numbers instead of working on the text. And if you see the last part, we have like data stored in a row format and data stored in a column format. Okay, so because, you know, when you write the data, writing row is much faster than writing in a column. So what we do is we store the data in rows initially. When we have like a specific buffer got filled, then computer will move that data from rows into the column tables. So when we are moving the data into column tables, remember, we have to rewrite the whole table again. If we have to insert one more record, we have to rewrite the whole table again. This is the cost which we are paying, but this cost is negligible, you know. Because of the speed, it takes maybe less than a second, you know, to write the whole table again. So is if you see here in this example, we have like a row store. The data is stored in a row. So whenever the data will write, it will write 1300, and then it will write DE, the country name, then 1400, and then DE. So it will write a row of record. So this is the row store. So when we will read the complete row, and then we will read another row, and then we will read another row. So we will be writing the rows and we'll be reading in rows. Now, when we talk about the column store, we are writing the columns first. And then if you have to read, we will read this column first, and we will read the customers. And then once it is finished, then we'll go for the country to read. That is how we store in column and we read in columns. And this reading is much faster for the analytical purposes. Any question here, guys? And you know, when we are saving in the data store, we need some indexing to access the data fast. So if you have seen, you might have seen the book, and then at the end of the book you have an index, you know, index of the book. So if you need to search for a topic, you just go to the index and find the topic and go to the page number and then directly jump to that page number. You don't have to wait for it. So that is what we call indexing. So similarly, in the row store, if you want to access fast, you have to make an index of that column. So you can search fast, directly jump to that record, and then wherever that record is in the database, you can directly jump to that part. So in this way you can. But in column store is already indexed, so you don't have to create the index. So if you're searching for something, it's already indexed, it is already in column, and you're reading very fast. Any question here, guys? Now, when we talk about data compression, if you see that data is stored, right, this is the row 1, name is Fred Smith, and the debit is 500, salary is 10,000, and this is the city and the state and the zip code. Now, what HANA do the data compression. And this data compression, it makes the data less costly to keep in the memory. And secondly, it's very fast. It speeds up the searches. The calculation is very fast. As I mentioned before, the text costs you a lot, but the numbers does not cost you much. So what we have done is, what the SAP HANA has done, they just created a dictionary, okay, of the table. So in that dictionary, it put the values. You see the symbols? It put the symbols in a number. And then the values on the... So give a number to every value. So for example, Fred Smith has a number 1 and 2. 500 has a number. Salary has a number. City has a number. Zip code has a number. So if you see here, instead of storing the real value, we are storing the codes. Every state has a code, every city has a code, this value has a code, So now we are storing the data in like 1, 2, 3, 4, 5 format, 6, 2, 3, 7, 5, like this one. Now, storing the data in numbers, and especially the small numbers, it's much faster, and it compresses as well. So instead of storing all the real values, and that will cost you, like 25 gigabyte of data, if you store in this way, it might cost you, megabytes maybe sometime. So whenever it has to, redo the data display for the display, it goes to the dictionary, and it says, okay, what is 2? 2 is Smith. Plus, it will display the Smith. What is 1? Is Fred. Okay, well, Fred Smith. What is 3? 3 is like 500. What is 4? Is like row number 1. 5 is like, the city and the state, something like that. So that is how we do the data compression. So we do the data compression with the help of, storing the key values, storing the symbols, and keep the pattern into the data dictionary. Any question, guys?
Yes, I have a question. If the compression directory is created by the user, or it will be created automatically by the database?
By database. System created that.
Yeah, clear.
Very less user interaction, especially from the database point of view. Now we have the data indexing. Before we used to create index, but now the system, when the data is available in the RAM, is already indexed, and we don't have to worry about it. So if you see here, we have the this is the index of tables, 1, 2, 3, 4, 5, 6, 7, 8, and we are storing the values like that. So access is very fast. This is now no data aggregation. As I mentioned before in our previous example, that we have like 1 million sales transactions every day. So for reporting database, we have to, do some processes and then we do some aggregation. So for example, I want to, at the end of the month, I have to, process how much business I'm doing with every country. So from 1 million records of transaction every day, what I will do is I will sum up the sales amount for that day for every country. So if we have like 190 countries, so then I should be getting 190 uh, 190 rows for every day. And similarly, for 30-day, we should be having 190 rows times 30. Like 570 rows maybe. So that was the aggregation that we were doing. But now imagine we are stuck to that aggregation now. If we want to do some other analysis, we cannot do because the data is available in that format. So we don't have the detail of the data. And secondly, when we move the data from the transactional database to the analytical, we don't take all the data. We just pick whatever is required for our reporting. So maybe today we don't have the vision for what kind of report we can have in the future. So whatever is the today's requirement, we'll just only go with that. So then we get stuck. So we can't do further, further exploration or further analytics. We cannot do. We are limited to what the data is available. So that was the problem in the previous database. So if you see here, we have like pre-aggregated data. Yani we did some aggregation and then we process, we get the report from those. But here the complete data is available. The complete data is available as is. So whatever the way you want to process your report, whatever the conditions you want to make, you can just do it on the fly, directly from the real data, no problem at all. So we eliminated, with having a data in the RAM, we eliminated the aggregation of the table. We do have some advantage of the column store, columnar database as compared to the row store. Is very efficient, higher cache efficiency, faster data aggregation, high compression rate. If it is a column based, we can do the parallel processing. So we have like 10 stacks of RAM servers. Every server is processing separately without any problem, and they're all working on the same problem. So faster read performance. This column database is very good for the reading. Row-based data is good for the writing. So faster read performance. The disadvantage is it takes some time. As I told you, if you added new records, it will recreate the whole table again in the column-based. So so it is less efficient for transactional processing. And if you want to add a transaction, for every transaction you have to recreate the whole table. Which is not the case in transactional database. When you're storing the data in row, that is okay, no problem. Slower relational interfaces. If you want to relate the two tables, make a relationship between them, then it is slower. Slower write performance. Writing of database definitely always a problem, especially in the columnar. because for every transaction, that is why we keep the buffer, maybe like 100 transaction or 200 transaction. Once they complete, then we rewrite the whole table, or maybe more than that. So depending on the buffer, so once the buffer is about to fill, that is the time we recreate the data, and we move the data from this buffer into the table, and then delete this buffer, and so we can add some more records into that buffer. So the initial writing is like row based, and from that row based we move the data to the column store database table. Any question, guys, here? If you see here, this is an example for the row based. This is my row 1, okay, guys? And if you see, and these are my column based store. So if you see here, it looks like same. Huh? The first row is same like this one. The second row is like same. Now, so it doesn't look any different, you know. But when you read or write in the row based, you're writing the whole record first. Yani USA 3000, DXTR 100, and then 5. So you will write the whole line. And then you will go for the second record, you write the whole line. Then you write the whole line. Now, if you want to read, you read the whole line again, and then you will read the whole line. For example, your query needs only that I want to know how many records we have from USA, how many sales we have made in USA and Germany. Okay. Now, so we need like 2 columns, huh? So we need the country column, and we need the price column, or sold pieces column, quantity column. Guys, if I need 2 columns in the row based, I have to read all 4 columns, whether I need it or not. I will read another 4 column, and then whatever I need, I'll keep it. Other things, I will remove it. I will ignore it. Now imagine I'm reading everything. I'm reading everything to get these 2 values. So I'll keep these 2 values, and rest I will just ignore it. So imagine it is costing me extra read. But if I have to read in a column based, I will just read 1 column, you see? And I will ignore the other column, and I can read this column. So my read will be just on that column. And if I'm writing, then writing will be again on the column base. So reading is much faster in this part. Writing is very costly. Here, writing is very simple, but the reading is very costly in the row based. Any question, guys?
So does this mean we are using SAP HANA mainly for analytics and creating reports, not in adding or writing data?
No, we are using for both purposes. We are using for transaction, and also we are using for reporting purposes. So what happened before, we were having 2 different servers, one for reporting, one for transaction. Now HANA actually merged both qualities. So HANA is having a transaction plus the reporting. So it is for both. So what is happening, when I have to write the records, I will write in rows. Imagine like that. So when my rows buffer filled, I will just move these rows into the column based. Bus. This is what I will be doing. My system, HANA, is doing. And then it will be empty this one. It will write 4 more rows, and then as soon as the buffer gets filled, it will move all the 4 rows again. It will add them into the column based table, and it will empty this one. So you see, what I'm doing is I'm writing in a row, but after some time, I'll push them, all the rows, into the column based table. So I'm doing actually both things. Now, most of the time when I put it into the column-based, so now I can read for the reporting purposes and everything. So writing part is not done here. Writing part is done in a small buffer, in a small, you can say small table, you can say that I can write in rows. So I'm doing both job in HANA. I'm writing the transactions, and also I am reading for reports as well from the same tables.
Okay, clear. I just have like one question.
Hmm.
What about editing? If we're so I should create the full raw format to be able to edit, or there is another solution?
Okay, if you have to edit, same thing. We will change, and then that change will go again. It will recreate the whole table. Simple. That is why we are saying writing is very costly here. But since it is in the RAM, so it doesn't matter. They found out it's okay. It's not a big deal. So it doesn't cause anything like slow or something. They didn't feel it. But everything is happening, in the RAM, so it's fast. Now, if you see here, as an example, so when we are reading, you see here, we are reading in RAM, this row based, we are reading the whole row. You see that? And then we go for the next row. Then we read the next row. Then we read the next row. But actually, we need only the city, or only we need the countries only. The information that we need is country. So you see that I am doing extra read here. But in this case, if I need the country, I can just read this column. Khalas. Only one column I'm reading. I'm not reading, I'm ignoring everything here. So the reading is much faster as compared to. So if I need to read the second column, which is, I don't know, which is the price or something like that, that is really, much faster. Just read one column. Now, if you see here, we have an example, select country from tables, okay? Select country from table. So I'm reading here countries, but how I'm reading? I will read everything here and then I will go for the next country. I will read everything here and then I will go for the next country. Read everything and then go for the next country. So I'm reading so much extra stuff. But in this case, I'll just go up there and read it. But here I'm reading from everywhere. You see that? All columns I'm reading. All columns I'm reading. But in this case, I'm just reading one column. This is column-based store. So basically, when I say reading or writing, actually, so row-based or column-based, actually it is the reading and the writing. How you write and how you read. This HANA is not a database only, it's a platform. You can develop application on this part, on SAP HANA. You can do real-time computing, You need a report now, you can go up to the last transaction. That happens few seconds before, which was not possible in the previous database structure when we were having database on the hard disk. And we were having like two databases, one for transaction, one for analytical. So that was not possible. The real-time computing was not possible. So real-time computing is only possible when we had the HANA database. It reduces the complexity, because we are managing the data in-memory computing. It removes the aggregation, it removes the indexing, it removes so many things, It saves a lot. And we can do the processing directly on the data. And this one, HANA, is available in the cloud and it is available in the on-premises, you can have it in your company, Some of the features for HANA is like, as I mentioned, it is in memory, multi-tenant, yani one database can be shared by many, many users, many customers can share one database. Multi-tier storage, yani we have different kinds of data. We have like, I'm not sure if the example is available here or maybe on the next slide. Multi-tier is like we are having what you call it. We have different types of data. We have hot data, we have warm data, we have cold data. So mission critical data. Mission critical data means data must be available all time you need it. The hot data means, okay, is like an email. Yani, if you get the email after 30 seconds or after 1 minute or after 2 minutes or after 10 minutes, no problem. It's okay. But if the mission critical data you get after 1 minute, oh, then you are in trouble. Imagine if you're going for your ticketing, okay, and every time he enter your information and you press enter and you have to wait for 1 minute, and then he enter anything and you have to wait for 1 minute, imagine how much loss they will have. So that is the mission critical data that you need in seconds, less than even seconds. So we have like, so this HANA database, in-memory database, also has a multi-tier storage capabilities. Yani the mission critical data is available in the RAM. The hot data is also available, maybe you can say on the hard disk. And the warm data is available in another database, and there's a link between the other database and the HANA database. The cold database is available in a backup. Okay, whenever you need it, you can load that database onto the hard disk, and then you can move it to the in memory. You can do the analysis, analyze text. You can do the analysis of text. You can do the analysis of streaming data. This streaming data is like, you have the sensors, and sensors are sending data all the time. So that is a kind of stream of data that is coming in a real time all the time. You can develop application, combining your analytical and transaction together. This is one of the HANA features. You can access data from any source, from internal or external. You have a data in Excel, no problem, you can import it. You have a data in XML format, no problem, you can import to the HANA. You have in Notepad format, in a text file, okay, no problem, you can import it. You have database, you have a data in another database, no problem, you can access data from any source. You do have a monitoring tool, administrative tool that you can work with, and it's protected and reliable. Everything is password protected. You can access control is there. Not any unauthorized access is not possible in HANA like other databases. Any question here, guys, before I move on to the next? Okay, this is the old platform. Okay, if you see here, this is the database management services which are available. You can say that it is HANA 1.0. Okay, at the moment we will be working on HANA 2.0, which is the latest one. Okay, and this HANA 1.0 SPS 12, this is the latest in the HANA 1.0. After this 12, it becomes HANA 2.0. So before we were having like HANA 1.0 SPS 1, then HANA 1.0 SPS 2, SPS 3. It comes up to SPS 12. So they were like making improvements and upgradation was happening until 12. After 12, they said, no, we are going to have SAP HANA 2 now. So these are the some facilities that they brought to SAP HANA 1.0. So they were having like management of database, database, all information is here. And if you see here, OLAP, OLTP plus OLAP, yani transaction processing and analytical processing. So online transaction processing plus online analytical processing, they merge together in HANA. So there's no movement of data from transaction database to analytical database. There is no aggregation from transaction to analytical. There is no indexing required. Okay. So everything is eliminated now. We have like application development platform. You can develop application on this HANA. You have like, this is like advanced analytical processing. You have like, predictive analysis. You can predict the customer trends, how the things are moving. Streaming analysis, the data is coming through the sensors and you're doing the analysis on that. Some business functions and search and text search, text analysis. Text analysis is like, you have a data in Word format, you have a data in, okay, imagine you have like Twitter. So people are writing in Twitter, anything. So there's no structure. They can write anything, whatever they want to. So the SAP has the capability to do the text analysis, okay? And we get some sentiment from that analysis about the people, what they are thinking, what they are talking about. Are they positive? Are they negative? Like that. One of the example, when there was a election in America, especially when the Hillary Clinton, she was fighting against, I don't know, with someone, I forgot the name of that guy. So Hillary Clinton, do you know that Hillary Clinton was fighting against whom?
John Biden.
Wasn't Trump or?
No, not with the Trump. It was with someone else.
John Biden.
Before Trump.
Before Trump.
Before Trump, before even, before Obama, even at the time of Obama and Hillary Clinton, they were trying to fight with each other. But since they were in the same party, so Obama got the chance, and this Hillary Clinton, but Hillary Clinton has someone in. So what was happening is when Hillary Clinton was giving the answer to the question, they had a TV program, and in that TV program, the anchor person asked a question. So people were writing on social media. People were writing on Twitter about their sentiments, whether they liked the answer of Hillary Clinton or they didn't like the answer, or they. So Hillary Clinton, she was having a notepad. On that notepad, they were doing the processing of all the Twitter in real time. And that was in HANA. And she was getting the real-time feedback about the people's sentiments. And so based on those sentiments, she was trying to cover up, answer in the next question. So, anything the people did not like, so she tried to cover up. So you can imagine, I mean, and SAP said, the guy who are providing us the services from SAP Magdeburg University, they also mentioned that, okay, we also run the same sentimental analysis for Hillary Clinton. And he says that our processing was on limited data because Twitter gave 10% of data for free. But if you want more than 10%, then you have to pay for that. So they say we did analysis on free data that we can access 10%. He says that our results and the Hillary Clinton, which she was getting from the full database, our results were same almost. 95% or 90%, they were the same results. So, I mean, this is what we are talking about, text analysis. That is also possible. So if we talk of data integration and equality and quality, yeah, you can integrate your HANA with any database, with even flat files, with Excel, with Access, with Hadoop, the big data database. You can integrate the data. You can access the data from any device or any database. This is what I'm talking of HANA 1.0, SPS 12. Okay, so in HANA 2.0, okay, now we are working on the SPS 5. So it means that SPS 1 and 2 and 3 and 4 are gone, and now we are on the 5. So hopefully when it will be 12, then they will have like SAP HANA 3.0. So now we have, like, again, same thing, database management services. I think we have, like, this relation was not available in SAP 1.0. And they created the relation of tables in this part. Okay, advanced compression was there, multi-tenancy was there, multi-tier was there, data modeling was there, but this part was, I didn't find this part in the previous one. Okay, let's go back and see. This is like relationship. Yeah, relationship is not here. It is openness is there, but it is not there. So, and similarly, in this HANA, we have like graph. Yeah, it was there before. I think series data, I'm not sure. And the document store, for sure, machine learning was not there before. Okay, predictive modeling is there, streaming analysis is there, enterprise search, I'm not sure it was there or not. So, they improved. They improved a lot of stuff in the this is analysis, analytical things, where you can do the predictive analysis and all those stuff. Application development, yes, they did improve in the application development as well. They did some, this is data virtualization and data integration with other databases. Yeah, it is there. And they brought some new stuff. So they are improving actually every time. So this is, in short, we have like advanced analytics, yeah, application development happening, database management is happening, data virtualization, this is integration is happening, and this is our database design. Now, if we look at the HANA hybrid landscape, hybrid landscape means you have on premises, okay, and some of the part is available on the cloud, okay, or you can have fully on premises, no problem, or you can have fully on cloud, no problem, or you can have some portion on the cloud and some on premises. So this is HANA has some success stories. Okay, guys, this I don't know, is Gabriel or something like that. They did implemented SAP HANA for real-time data analysis. Okay, so they did it for data analysis, not for the what you call it. It was for reporting purposes, not for that their ERP is having real-time data on HANA. No, not like that. So they are using HANA for you can say that for analytical purposes. So they did implemented that, and they wanted to keep their real data, original data on their old servers, old what you call old software. They don't want to mess up with that, but they really need the data analysis on SAP HANA. So this is a success story. Let's see if I can find some of the information for this. Okay, that information. I think this company is like, maybe 200 years old company that they are working on that. Bridgestone has a success story, they 25% reduction in error with real-time visibility. Oh, imagine 25% reduction in errors. Costain has 66% lower IT infrastructure cost. So, it helped them a lot. We have another one. This is like the University of Munich, in Germany. They did some analysis, analysis on protein analysis. This is a protein analysis. We have good protein and we have bad proteins in our body. And those bad proteins cause cancers, or because of the cancer, we got some bad proteins. Now, doing the protein analysis is very tedious job. Before, they say, okay, we can do the protein analysis on our supercomputers, but it will take like 5 to 6 months to process all the variations of proteins and see what the result is. So imagine supercomputer for 6 months running on proteins for one person. It cost a lot. It was impossible. Now, because of the HANA database, they were able to do it in you can say that in seconds or minutes or something like that. They say the patient comes in and they do the analysis of their protein, and before the patient leaves, the doctor has his report from the analysis. So that is such a big breakthrough in the human history, So now NFL, I think they have this a league, football league maybe. So that enables the fan to see the complete history of team and do analysis of any kind. Before, they were having limited information available, but now since they have put all the data on the HANA, so they can, they can do any combination of statistics, any combination of statistics. They can, the users can find for their fans, fans can find for their players they like, or the teams they like. So all the data is available on HANA now. So these are some of the success story for HANA. We can have HANA for data warehouse, okay, and we can have HANA for our real-time data. That is possible. If you see here, this guy, they put it for data warehousing, for all the data analysis on the HANA. So basically, this is what we call data warehousing strategy for the HANA. We are using HANA for data warehousing for analytical purposes only. What you'll be capable of, we can access the data from any source into HANA. HANA has tables. Then, so first of all, we do the data provisioning, okay? We provide the data. Then we put the data into the tables. Then we create the views. So 3 things are happening on the database level, okay? And these are kind of calculation views. So everything is happening on database, and you can just move this information to the application front end. You can display on the application that is connected to the HANA, or you can display on the web page if you are accessing through the web. So HANA is capable of getting data from any source, whether it's ERP or supply chain or data warehousing or third party or Excel or flat file or any data file. It goes through the data provisioning, it goes to the table, and then we have created the views, and that can go to the application, or you can display on the web-based. Guys, this is our task. We will be doing, inshallah, we'll be doing the data provisioning from third-party database, okay? This is what we are planning to do. So we will be reading from flat file or Excel file or some other data. Through the data provisioning, we'll move the data into the tables, inshallah, and then we will create the views. And then we will see the views on the software or on the web-based. This is what we'll be doing. Any question here, guys? Okay. Now, guys, whenever we're talking about calculation view, okay? Now, remember one thing, guys, and this is very important from the knowledge point of view. Guys, we have two things. One is dimension and one is fact. Okay, guys? One is dimension and the other is fact table. Dimension table, fact table. Okay, guys? Remember, in data analytics, when we are doing the reports, two main things: dimension and facts. So we have a dimension table and we have fact table. Now, what is the difference between dimension table and fact table? Guys, dimension, there is no calculation involved. You cannot do any plus minus. For example, dimension could be a customer, dimension could be a country, dimension could be a city. You want a report based on city. This is one dimension of report. You want to have report on a country base. Oh, country is a dimension. You want to have a report on sales organization. So in America, we have two sales organization, East and the West. So that sales organization, I want to report on East sales organization. Okay, this is one dimension. Okay, guys. Germany has two, Germany North and Germany South sales organization. Okay, I want to report on Germany North sales organization. Okay, this is one dimension of the report. Guys, is that clear? At least dimension part is clear before I move on to the fact table. Okay, fact table. Okay, this is also another dimension. This was a customer dimension. Customer number, and the customer has a country and customer has a sales organization. Okay, so these are the dimension. Do you see any number that you can use for calculation? You will never find any number that you can use for calculation in the dimension view. In any dimension, you will never find a column that has a number and you can do the calculation. Okay, is that clear? You may have a column which has a number, but you will never be able to use it in calculation. But remember this thing. Maybe we have a column like credit limit for the customer. The credit limit is $10,000. $5,000, $6,000, $10,000. Yeah, it is available. But since it is a dimension table, the customer is a dimension table, we treated him as a dimension table, you will never be able to use that column in the calculation. Khalas. You can count them, but you cannot use them in calculation. That is what dimension means. Now we have another table. So this was a customer table. Now we have a product table. So by the way, we will be using these two tables in our exercise. So customer table, and now we have a product table. Product table has a product name and a product number and a size and the product group. And then we have some kind of sales organization, and then we have a color of the product. So since this is a product dimension, okay, every column in the table can be used as a dimension of the report. Okay, I'm looking for the product which is a yellow color. Okay, so the yellow color, So I'll be having report on the yellow color or the white color. So maybe I have like 4 colors. So I want to see the sales of all these 4 colors. So it will count, it will group all the products based on 4 colors. So I will be having like 4 main values at the end of the day. Does that make sense, guys? And now if you see here, we have 2 tables. One is sales organization table, one is product table. So no problem, we can have any, and this table has a color and this table has other information. So we created them as a dimension. So these 2 dimensions will be used in the report. We are using in the report as an example here. Now, this is a fact table. If you see, the sales is a fact table. How much items were sold? What was the price of the product that you sold for this 4 quantity or 7 quantity or 3 quantity? So you will be having which year you have sold, the date of sale, the customer, and the products, and so this is the fact table. This is the customer dimension table. This is the product dimension table. Now you see that we are linking the dimension table with the fact table. And now at the end we got a big table, which has a column from the customer, we have a column from the product like color, and then we have columns from the fact table. And from this table, basically we can create the reports or we can do the analysis, or we can create the analytics. Guys, how many of you are familiar with the select statement in database? Select statement in database. Can you please write in the chat? If you're not familiar, no problem. Say I don't know. Okay, good. Then nobody. So what I'm trying to say is that in select statement, you can link 3 tables, 2 tables, 4 tables, and at the end, you can display columns from all 2 tables or 3 tables or 4 tables, whatever that is what you can do in the select statement. Okay, we already talked about that, when to use which table view for reporting, that is what we have to, find it out. Fast calculation on the database level. So what happens, SAP has done, they moved all the calculation, everything on the database level. So that is why on the application level, we get nothing. We don't do any calculation on the application level. You know what was happening before? Guys, there were like 2 databases, 2 servers. One was a database server and one was an application server. So since database does not have the capability of calculations, so what we do, we read all the data from database server and we process on the application server through the programs, and then we print the result. Okay, this is what was happening before and now even in most of the companies. So when we read the whole table, imagine if it has millions of records, so the millions of records will transfer from one server to another application server. Imagine the traffic which will happen on that read. So that read was very costly. At the end of the day, when we process those million records and we get one line as an output to display, so this was like very costly, traffic movement, and from one server to another, then you're reading and doing processing on the application and program is not that efficient. It is taking a lot of time. Now what SAP has done, they pushed all the logic onto the hardware, onto the database. So if you need to work on million records, the million records will be worked on the database level. And you get just one line. So you see, there is no movement even, just one line movement instead of 1 million lines of movement. So this is what, we cannot, we don't have the data aggregate. Data aggregate will be created on the fly, when you want it, it will do the aggregation. It's not required to save data physically. Yeah, before data aggregation, we have to, do the aggregation and write the data into another table. No more data saving on the data is saved once on the most detailed level. So our data is available in HANA. Data is available until the last detail level. So we don't have to worry about aggregation and all those stuff. So we have a tables, like column tables available in the in-memory database. We do have row tables. Remember, row tables, sometime, maybe we have a small table, a small fixed table, has like 10 rows or 100 rows and is not changing all the time. We can keep that table into the row format, no problem. But if we are using that table for all the time for processing, and then it should be a columns table in HANA. We will create from these tables, whether it's a row table or is a column table, we will create the calculation view. This is our task, okay? We will be doing, and this will bring the what you call it, this will bring the output or analytics what we want for decision making. These four, the boxes, these are the dimensions, and the middle one is the fact table, like we have already just seen. This is a fact table in the middle, and the right side and the left side and the top here and there, these are the dimension tables. So the corners are the dimension tables, and this is the fact table. So this means that we are working on the calculation view. This is the sign for the calculation view. This extended application service, XSA, SAP HANA, as I mentioned, is a platform. You can develop the application on this one. So this is what we have for XSA HANA, SAP HANA XSA. This is the platform where you can develop the application. This is again, you can have any develop application in HTML and Java and C#. You can take the best of every language and you can embed. So before, what was happening? Oh, I can work on HTML, but I cannot link the HTML with Java. Oh, C++. Oh, C. No, now it is possible with the help of this XSA that you can develop the software in any language and you can embed into your application which you develop on SAP HANA. That is no problem. So the main feature of HANA XSA, okay, you can embed service. So it's this HANA support web-based application development from start till end. Okay, you have the administration tool available that you can administer your application and the runtime. This is you develop this is polyglot application development. Means you can use any language which you have, and then you can embed that language into that function into your application you develop on SAP HANA. That's it, guys. This is again, Cloud Foundry is also one of the concept that you will find in SAP HANA XSA. Okay, so that's it for Any question, guys, in for this SAP HANA?